Hello. We are the Team Icon, and we will be presenting on the topic Helper Solutions for People with Physical Disabilities. We have developed robots to enhance daily living and well-being. People with physical disabilities face challenges that limit their mobility and independence, making it difficult to complete simple tasks without help. Helper robots that can help with these tasks provide significant improvements in daily life. Our proposed solution seeks to solve the difficulties by combining the Turtlebot with robotic arms and facial recognition functions. The proposed system consists of user, program, and robot. The user controls it manually or moves the eyes and lips. The program recognizes this and sends commands to the robot to move. Now, let's introduce the software part of our project. Raspberry Pi gives commands to control the robot arm and drive unit. Communicate with users via TCP and HTTP, transmitting the video captured by the camera mounted on the robot. OpenSHI controls the connected motor by receiving commands for control of the drive unit through USB serial communication from the Raspberry Pi. Arduino controls the 5 connected servo motors by receiving robot arm control commands from Raspberry Pi. By manipulating, the servo motor can pick up and move objects. Use Open and DIV libraries. It can read the video from the user's webcam. After that, the feature point of the face is detected and processed through the detector function of the OpenSHI and the directly defined detector function. This is an MFC-based application. You can check the current camera status on the screen at the top screen. The interface below allows you to enter operating elements according to movement. This allows you to manipulate the robot through facial recognition. Now I'm going to explain about robot arms. The robot arm consists of 4 servo motors for adjusting the position of the arm and 1 servo motor for grasping. This is controlled through Arduino. For the control of this robot arm, it is necessary to use a serial port to put a command in Arduino. Therefore, language C was used for the entire development process. The 5 servo motors have their respective roles, and we used Arduino Mini for control and capacitors for voltage stabilization. The frame of the robot arm was designed directly through an AutoCAD and manufactured through a 3D printer. Let me explain the 5 servo motors. A determines the azimuth of the robot arm. B and C control the main frame of the 2 robot arms. D determines the direction of the tongs, and E controls the robotic arm tongs. Depending on the movement of the robot arm, the angle of the arm is calculated as shown in the following figure. As I explained, the robot arm is manipulated according to changes in the face. If you look at the picture below, your arms are manipulated according to the movement of your eyes. The tongs move according to the shape of the mouth. All of these can be set through the program. Now let's look at the actual motion. You can check your current face status through the program, and you can see the robot's arm moving according to facial changes on the left screen. Successful. In conclusion, we will have time to evaluate the applicability of the project. We conducted volunteer work and interviews at the Welfare Center. It has been evaluated that developing robots based on facial movements can help many people with disabilities. It will also be applicable as an alternative communication system, AAC. To address this challenge, the interface needs to be improved to make it easier to use. Many tests also require improvements in facial recognition algorithms. Based on this, it will be a solution that will help many socially disadvantaged people. That's the end of the presentation. We will try to think more and develop technology for the socially disadvantaged. Thank you.